Okay, hello. This video will cover this week's work starting from 3B. So the data portion. I'm not going to do the whole data portion of the worksheet. I'm only going to do the first two boxes. So the one that is the theoretical probability box and the one that's the one actually of us actually doing the experiment ourselves. And I'm doing this also because I know the dice thing isn't working for everybody at the moment. So if you can't do it, you can jump ahead, but I'll do the experiment here and I'll tally it up as we go, and you can watch it alongside as we do it, or you can skip ahead when we do that and steal the final results off of me, the tally and the frequency and stuff like that. But anyway, let's start here because we do need to cover ground. If I only do the dice, I don't think it makes too much coherent sense. So let's start here. Cool. This is the dice. The 114656, the red dice and the yellow dice, or die to be technically correct. I've made that here on the left. So I've already made the red die to have two ones, a 4 and a 5, and two 6s. The yellow die, I've done the same thing. I've made it so that it's two 1s, two 3s, a 5, and a 6. So I've made it to match our question. So these are the two dice we'll use. We know, just to remind ourselves the game, if the sum of the dice is 9 or more, the participant wins a prize. If the sum of the dice is 8 or less, the participant does not win a prize. Now, even though the reason why we don't simply say what we win and what we lose is because we're still in data and analysis phase. In those places, we still want to write down everything that we do and all the results that we get. And it's only at the very end of this cycle, right? The PPDAC cycle. It's almost near the end when we're in the conclusion that we say, yes, so winning percentage, this and this much, losing percentage, this and this much. So that's why in this case, we're still doing all of these things. So let's talk about the theoretical probability. Dice 1 red. What are the possible outcomes we can get from dice red? It's a 1, 1, 4, 5, and two 6s, I believe. Okay, dice yellow, it's 1, 1, 3, 3, 5, 6. Okay, so we are adding them up. It is the sum. So inside this area, we will write down all the sums, right? So if I rolled a 1 and a 1, that's a 2. That results in the 2. We all know these will all be 2s. And then I'm just going to go and fill them in. So I am adding this side here and this side here, the two numbers, and I'm writing them down. So let's just do them all. Okay, so there we have it. These are all the probabilities, right? The way that we can get these results. Okay, cool. Now, because we know a die works quite fairly, right? If it is a cube die, we know all of these 6 individual chances here, they are just as likely. They have the same probability. So we're saying each of these squares in here have the same probability of occurring. Cool. Now they can only, they're only more probable if there are more of them. Or like this 2, there's quite a few 2s. And that's what will work out. So anyway, those are all the probabilities. Let's go to this left side. Not left side, sorry, right side, this part. We actually need a little more. And I wrote this before. You need to add some rows. This is just a screenshot image, so I can't really add rows into this one. But let's think about all the possible outcomes we can get, all our sums. If you look carefully, we actually see inside here that there are no 3s. We actually can't get a 3. So that's a 4, 5, 6, 7, 8, 9, 10, 11, and I think we can get up to 12. And cool. Now, theoretical probability, there's two rows here. I'll probably use one for fractions and the other for maybe percentages. So wait, let's have a look. How many are there in this area? How many are there? You can't count it up, or you can go how many of this and how many of this and multiply them. So 6 times 6. Or you can't count it up, but we end up getting 36. There are 36 total possible outcomes. Okay, in here, inside our grid right over here, how many 2's are there? And I can see 4. So I say 4 out of 36. Right? How many 4's are there? I can actually see another 4. So I'm just going to say 4 out of 36. And we can simplify it, but for the time being, I'm just gonna run with it. How many 5's can I see there? I can actually just see 2. How many 6's? I see 4. How many 7's? I see 1, 2, 3, 4, 5, 6, 7, 8. 8 7's. All right. How many 8's do I see? I see 2. How many 9's do I see? I see 5. Oh, is that the first odd number? How many 10's do I see? I see 2. Oops, a daisy. How many 11's do I see? I see 3. How many 12's? I see 2. All right, so that's all the probability in fractions. So the probability of getting a 2 is 4 over 36, or you can't simplify that. But anyway, if I want to go percentages, I go 4 divided by 36, or you can say, you can write the fraction, then times 100. So again, 4 divided by 36, click it, and then times it by 100. So we see that it's around 11.1%. So same for this. Let's do it for all of them. Oh, well, we know all the 3 over 36's are 11.1%. So 2 divided by 36 is 5 point. Well, let's keep it 1 decimal point in a percentage. So 5.6%, 5.6%, 5.6%, one more, 5.6%. Yeah, I know this isn't very neat, but when you are typing it in on your worksheet, it should be much neater. For 7, 8 over 36, so 8 divided by 36 times 100, you get 22.2%. That seems the highest one so far. It's actually the highest one we get. 7 is the most common outcome we can get in this game. So the 9, there are 5 of them, so 5, you get 13.9%. 3 divided by 36 is 8.3%. Okay, cool. These are our theoretical probabilities, saying, assuming that they're all just as likely, that the dice are fair, we get these. Or when I say fair, I mean the 6 sides are all just as likely. And that's the probability of getting those results. And we can talk about that later, but talking about it, I guess, falls into analysis. It's the next part. So since we're in data, this 3B area is just data. Let's go and collect more data. So that's one. That's a good chunk of working right there. Boom, on to the next. Now we are going to make. I use the dice on this side, on the left. Right. If you remember from last week, we want to be at least 30. 30 times is the minimum. So let's just go to a clean 50. You can definitely do more, but I'm just going to use 50, and I'm going to roll the dice and try it out 50 times and see what I get on the tally. So here we go. I've already pre-made the dice like I've explained. Boom, boom. I get 5 and I get a 6, so that's 11. Boom, that's a tally there. Actually, I shouldn't start in the middle, start on the side. So this might take a while, but I'm going to do this 50 times. I hope I don't forget how many times I've done it. But anyway, I'm going to actually do this. I'm not going to edit this very much. Okay, talking and counting is very hard. Actually, maybe I will edit it. I'm going to do this 50 times, like so, and got a 2. And we'll see with the chart that we get. If yours doesn't work and you can't get the dice to work like this and the website doesn't work, you can just take this tally outcome that we're getting. So we're just doing it one by one like this, and we would have just repeated this several times and see what we got. Right? Just like so. 8. Oh, why didn't that roll? Okay, 12. And then, yeah, I'm gonna cut and meet you after I've done 50 of these. All right, see ya. Okay, I said I was going to do 50. I actually didn't do 50. I just went on and I did 100. I was at 50, and then I thought, this doesn't show the probability enough. I reckon do more and we'll get a better set of data. So I've done 100. So frequency just means how many you got. So I got 8 of 2. So I got 8 there. Probabilities, of course, in a fraction, it's because I've done it 100 times. It's 8 out of 100, which is quite nice, which is because that's just 8%. And this is 12%. And this is 5, 13, 23, 7, 12%, 6%, 8%, 6%. So, yep, I don't have to work too hard. It's 8 over 100, which is also just 8%. Cool. There we've got it there. You can, of course, put this on Google Sheets and then make the graph, but I'm not going to make the graph in this video. If you do want me to show you making the graph on Google Sheets so you can put it on your document, please let me know, and I'm sure I could do that. But as far as this video goes, here's the table you can use if your dice page does not work for you. Okay. Otherwise, yeah, you can have a look and you can see if and compare with your theoretical probability, see if it lines up a bit, or do you think it does not line up at all? The reason I did 100 was because, yeah, I just felt like 50 is quite small. So I just thought I might get more. So I did actually do it 100 times. There it is. You can use this just the same. I won't say that's copying. I will say, in the case of your website not working, definitely. So there it is. All right. All the best. Email me if you have any questions. And yeah, have a lovely day.